Bored. I'm so bored. Is there not a single case in all of the city?
Sherlock, I'm still working on last night's blog post. Maybe we should take a little rest. What do you say?
Dear God, what is it like in all of your funny minds? It must be so boring. I need a case, John. I can't keep living this miserable life.
When will I ever get a rest?
What was that?
Oh, nothing.
Sherlock, a case has come up regarding a boy on a roundabout. We need your help. Now. You know where to go. Lestrade.
What is it?
No time to explain, John. The game is on.
A few moments later.
Alright boys, take a look at this video. We got it from the officials this morning and people are losing their minds over it. Perhaps you could explain it.
So you want us to explain why the boy flew off the roundabout?
Yes, you want us to find out what caused him to?
Precisely. That's not all boys, check this out. There seems to be some sort of correlation between these cases.
So did you catch any suspects?
The cameras caught a glimpse of a car speeding around the corner. We're looking at the license plate and we're currently trying to track down the suspect.
What are you waiting for? Show me the footage of the car. There's no way it was the driver. It happened too fast.
This could happen to anyone. We need to find a culprit. I'll give you 2 minutes.
2 very boring minutes later.
Of course, it's physics.
What do you mean physics? There has to be a person connecting all these cases.
You seriously can't see this. It's so obvious.
What do you mean? Please explain.
It's centripetal forces.
What?
Oh Lord, please help me.
Well, first of all, the motion of an object in a circular path can be explained by the concept called circular motion. Basically, when you are moving in a circle with a constant speed, you have centripetal acceleration due to the fact that your direction is changing. You can calculate centripetal acceleration by squaring the linear velocity and dividing that by the radius of the circle. Keep in mind that this is always towards the center of the circle. As for centripetal forces, they can be calculated by force equals mass times centripetal acceleration. Also, force equals mass times velocity squared over r. This is because of Newton's second law, force equals mass times acceleration. The centripetal forces is what keeps the object moving in a circular path. Based on these equations, as the radius increases, the force decreases. They have an inverse relationship. Then, when the mass or velocity increases, the force increases too. This is because they have a direct relationship.
I still don't understand.
What we're trying to say here is that the people in the videos were victims of the properties of circular motion. For example, the man on the roundabout flew out because his linear velocity made him continue on.
Centripetal acceleration is, like Sherlock said, a vector which always points towards the center of the circle. In the third scenario with the car, the vehicle had a tangential velocity to the road, but the tire changes direction and the car experiences a force of static friction causing a centripetal acceleration towards the center of the circle. Sometimes centripetal force will be tension, friction, the force of gravity, the normal force, or a combination of these or other forces. With the car, the friction between the tires and the road is what provides the centripetal forces.
And in the case with the swing,
the centripetal force of the swing is actually the tension in the metal rod that swings the person's platform around. So basically, the force of tension is equal to centripetal force, since it's the thing that keeps it continuing to revolve. Now, there's also something called the period and frequency. The period of the swing is the time it takes for one complete swing or one revolution around the bar, and this is measured in seconds. Frequency is the inverse of the period. It measures the number of revolutions in a second, and the unit for frequency is hertz.
Looks like someone has been studying up on space after that whole event.
Don't get me started on space.
So all objects experience a gravitational force between one another, even in space. A gravitational force is basically the mutual force of attraction between particles of matter. The equation for the force of gravity is the universal gravitational constant, which is 6.673 times 10 to the negative 11 power times the mass of the first and second object all over radius squared. The force of gravity and the gravitational constant and the two masses all have a direct relationship, while the radius and the force of gravity have an inverse relationship. The radius is the distance from the center of one object and the other. Keep in mind, Newton's third law still applies. The force on the first object is equal to the force on the second object. They form an action-reaction pair.
Looks like someone has been studying up on space after that whole event.
Sherlock has, I remember now, he was blabbing on and on about how we can float in space.
The floating is due to free fall and the gravitational force of another object. Although the person may feel weightless, they really aren't. This is because there will always be a gravitational force from a body that pulls it towards something else, no matter where you are. It just gets smaller and smaller. This gravitational force causes objects to be in orbit. The gravity is the centripetal force, and it causes things to be in constant free fall.
You two amaze me with all the knowledge you keep in your brains. Is there anything else you want to add?
I think Sherlock is forgetting one last concept.
A satellite is a smaller body that orbits a larger one. This is like the moon to the Earth. A satellite must have a specific speed in order to maintain its orbit around the larger body, and this is found using the centripetal and gravitational force. In this case, the centripetal force is equal to the gravitational force, meaning that we can put the two equations equal to one another. In the end, we get that the velocity required to maintain orbit around a specific body is found using square root of the universal gravitational constant times the mass of the larger body all over radius. The mass of the satellite doesn't matter, because this is specific to the larger body, unless the distance between the two objects is different. You can also find the free fall acceleration of an unknown object. The equation is the universal gravitational constant times the mass of the planet all over radius squared. Just remember that our weight changes when we're on a different planet.
Wow, well thank you for the help, Sherlock and Watson. So the culprit is physics, specifically its twins, centripetal force and centripetal acceleration.
Are you sure you don't need another example to keep these concepts stuck in that simple brain of yours?
Don't be rude, Sherlock.
Wait a minute, let me give it a try. Let's take a marble spinning around in a cup, for example. As you can see, the glass provides a normal force on the marble. In exchange, the marble pushes back with the same amount of force on the glass, creating an action-reaction pair. This then allows the marble to move around the edge of the glass. The normal force in this case is the centripetal force.
There's always bound to be another case popping up soon.
Farewell, and don't forget to hook us up with the next case.
You know where to find us, 221B Baker Street.